I'm Jaden, and this is Ivy.
Today we're going to explain an important concept in trigonometry, the unit circle.
Where should we begin?
What is a unit circle?
Good question. A unit circle is a circle with a radius of exactly 1 unit and its center is located at the origin on a coordinate plane. Because the radius is always 1, yet every point on the circle is exactly 1 unit away from the center. This simple definition is what makes the unit circle extremely useful in pre-calculus and trigonometry. It connects angles, coordinates, and trigonometric functions like sine and cosine. Now, Ivy, I have a question for you. What is the difference between degrees and radians?
Radians and degrees are the two ways angles can be measured on a unit circle. Degrees are the system most people already know. A full circle is 360 degrees, meaning each degree represents 1 out of 360 of a circle. Radians is slightly different. Instead of dividing a circle into 360 parts, it's divided into 2 pi radians. Radians are based on the relationship between the radius of a circle and the arc length along the circle. A key relationship to remember is that 360 degrees equals 2 pi radians. This relationship is what we use to convert between the two systems. So Jaden, how can we convert between radians and degrees?
That is
To
a good
convert
question.
radians to degrees, multiply the radian by 180 over pi. And to convert a degree to a radian, multiply by pi over 180. As an example, we can convert 90 degrees to a radian by multiplying it by pi over 180. 90 divided by 180 is 1/2. So 1/2 times pi is pi over 2, which on a unit circle is equal to 90 degrees. And now to convert a radian to degrees, we can convert pi over 3. We can multiply it by 180 over pi. The pi's cancel out. 180 divided by 3 is 60 degrees.
Good question. Now that we're back,
Unit circle.
Ivy, can you explain to us the difference between exact radians and approximate radians?
Radians are often written in their exact forms, where the pi symbol is still included, like pi over 2, pi over 3, or even 5 pi over 6. Sometimes we want to use a decimal approximation when solving problems. To do this, substitute 3.14 for pi or use the pi button directly in the calculator.
Now I'm going to explain how to graph an angle in standard position. Standard position means we write the vertex at the origin and the initial side lies along the positive x-axis. To graph an angle, start at the positive x-axis and rotate around the origin. If the angle is positive, rotate counterclockwise, and if the angle is negative, rotate clockwise. The line where the rotation stops is called the terminal side.
A unit circle can be split into 12 equal 30-degree sections. Each section is the equivalent of pi over 6 radians.
The circle can be divided into 8 sections of 45 degrees. Each step increases by pi over 4 radians.
Another common division uses 60-degree angles. These divide the circle into 6 equal parts, which also are equivalent to pi over 3 radians.
Some angles land exactly on the x-axis or the y-axis. These are called quadrantal angles. They occur at these points. These angles divide the coordinate plane into 4 quadrants.
Each point on the unit circle represents coordinates that correspond to trigonometric values. The coordinates follow the pattern of cosine theta, sine theta, as cosine equals x over radius and sine equals y over radius. For example,
The coordinates follow the pattern of cosine theta and sine theta. For example, 0 degrees is equal to 1, 0. 90 is equal to 0, 1. 180 degrees is equal to negative 1, 0. And 270 degrees is equal to 0, negative 1. These points allow us to find sine and cosine values directly from the unit circle.
Coordinates on the unit circle come from special right triangles. A 45, 90, 45 triangle has side ratios of 1 to 1 to root 2. Since the radius of the unit circle is 1, the hypotenuse of the triangle is 1. This gives us the coordinates for 45 degrees as root 2 over 2 and root 2 over 2.
Another special triangle is the 30, 60, 90 triangle. Side ratios are x, x root 3, and 2x. If the hypotenuse equals 1, then x equals 1/2, and the other side becomes root 3 over 2. This gives the coordinates 30 degrees is root 3 over 2, comma 1/2, and 60 degrees is 1/2, comma root 3 over 2. These values repeat in different quadrants around the unit circle.
Here's a new example. If you have a right triangle that is not 45, 60, or 30, you can use one of your trigonometric ratios like sine, cosine, or tangent. This angle, we can see that it is in the upper right corner. So sine is opposite of hypotenuse. We do not have the hypotenuse, but we do have the adjacent side. So we can use tan of 67 is x, the opposite, over 14, the
Adjacent.
value, and now equals. Now we can multiply the tan of 67 degrees by 14, which will equal x. If you plug it out, you can plug this into a calculator, but make sure you are in the degree mode instead of radians or it won't work. When you plug this into a calculator, you get x equals 32.98.